You remember absolutely nothing before age 3. Nothing. And if you think you do, you're probably wrong. That birthday memory? Someone told you that story so many times your brain just claimed it. Congratulations. Your brain has been gaslighting you your entire life. This isn't just you being forgetful. Every single human on Earth has almost zero memories from their earliest years, and scientists have been losing their minds trying to figure out why for over 100 years. So, why do we forget our childhoods? Why does the most intense, emotional, sensory overloaded period of your life just vanish? You were there. You were experiencing things. You felt emotions. You learned to walk, to talk, to recognize faces. And yet, nothing. Just gone. This is called infantile amnesia, and it is one of the weirdest, most unsettling things about being human. Sigmund Freud was the first person to formally name this back in 1905. He thought we were actively burying these memories because they were too primal, too weird. Classic Freud. He was wrong, but he put the question on the table. If children are clearly forming memories and learning at an insane rate, why do adults have almost no access to those memories? For a long time, the working theory was simple. Babies just don't have the brain hardware yet. The hippocampus, your brain's memory filing cabinet, isn't fully developed until around age 3 or 4. So the reasoning went, if the filing cabinet isn't there, nothing gets filed. Problem solved. Except it's not that simple. Because here's the catch. Children actually do form memories. Patricia Bauer, a developmental psychologist at Emory University, spent years studying this. She found that kids as young as 9 months can remember specific events and sequences of actions. They demonstrate this through behavior. They can reenact something they were shown weeks earlier. They respond to familiar versus unfamiliar stimuli in measurable ways. So the memories are being formed. They exist. Somewhere in that tiny, chaotic little brain, something is being stored. And then, years later, an adult tries to access those memories and finds a wall. Static. Nothing. So where do they go? Okay, this is the part that is actually kind of terrifying. A neuroscientist named Paul Franklin at the Hospital for Sick Children in Toronto, yes, that is the actual name of the institution, ran experiments with mice that fundamentally changed how scientists think about this. He and his colleague Sheena Jocelyn discovered something called neurogenesis-induced forgetting, which basically means new brain cells delete old memories. Here's how it works. Your hippocampus is one of the very few regions of the adult brain that grows new neurons throughout your life. In young children, this process is happening at an absolutely explosive rate. The brain is generating new neurons constantly, aggressively, almost violently. And when new neurons integrate into an existing memory network, they disrupt it. They break the connections that held that memory in place. It is like renovating a house while people are still living in it. Except the construction crew does not care about your stuff. They just knock everything down and rebuild. You end up with a better house. But your grandmother's china? Gone. In Franklin and Jocelyn's experiments, mice with higher rates of neurogenesis forgot more. When they suppressed neurogenesis, the mice retained memories they would otherwise have lost. When they boosted neurogenesis in adult mice, those mice also forgot things faster. Your brain, in trying to build itself, destroys itself. It destroys parts of the record of its own experience, which is genuinely one of the most poetic and horrible things I have ever learned about neuroscience. But wait, it gets more complicated. Because neurogenesis alone does not explain everything. There is another layer here that is even more interesting. Memory is not just biology. Memory is language. Try to describe a memory from before you could talk. Not narrate it to yourself. Actually experience it the way you would have at the time. No labels. No story structure. No, and then this happened. Just raw sensation. You cannot. Because your brain does not work that way anymore. This is what researchers call the language hypothesis. The idea that episodic memory, where you are the protagonist of a story with a beginning, middle, and end, is fundamentally tied to the development of language. Before you had words for things, your experiences were not being encoded in a narrative framework. They were not being tagged with "this is me," "this is here," "this is now." They were just happening. And when you try to retrieve a preverbal memory as a verbal, story-forming adult, the format does not match. It is like trying to open a file your current operating system cannot read. The data might technically still be there, but you have no way to access it. Mark Howe, a memory researcher at City University of London, has done fascinating work on this. He found that not only do you need language, you also need a sense of self. You need to understand that you are a you, that there is a continuous, named, persistent person walking around in the world having experiences. Young children develop this self-concept gradually, somewhere between ages 2 and 4. Before you knew you were you, there was no you to remember things happening to. That is either really profound or really upsetting. Possibly both. If your brain is not melting yet, hit subscribe. We drop a new video every single day. Seriously, subscribe. It is free. And this stuff only gets weirder. So let us add this all up. You have rapid neurogenesis destroying early memory traces. You have a preverbal encoding system incompatible with adult retrieval. You have a self-concept that did not fully exist yet. And you have a hippocampus that was literally still under construction. No wonder you cannot remember anything. Your earliest memories were stored in a format your current hardware cannot read, by a contractor who kept deleting files to make room for new construction, in a building where the main resident had not even been introduced to themselves yet. And yet, some things do survive. Most people have what is called their earliest memory. It is almost always from around ages 3 to 4, right at the edge of this amnesia window. And across cultures, these first memories tend to share specific qualities. They are often emotionally charged. They involve something unusual, something that felt different. Researchers believe this is because emotional arousal activates the amygdala, which signals the hippocampus that something worth keeping just happened. Your brain was basically a very disorganized librarian who only bothered to file the dramatic stuff. Which explains a lot, honestly. There is also something called boundary effects. Memory formation is stronger when something signals a transition, when the context changes. First days, new places, strange sensations. Your earliest memories cluster around these transition points because those are exactly when your brain was most alert. You remember the first day at a new house. You remember a strange dog. You remember being at a hospital. You do not remember the thousands of ordinary Tuesday mornings before and after. And that is by design. Your brain is not trying to document your life. It is not a camera. It is a prediction machine. Its job is to extract patterns, learn rules, and prepare you for the future, not to archive your past. The reason you remember emotional, novel, contextually distinct moments is because those are the moments most likely to teach your brain something useful. Your childhood was not deleted. It was processed. The lessons stayed. The timestamps did not. Here is the other thing no one really talks about. The memories you think you have from early childhood, a significant portion might be entirely fake. Not maliciously fake, just reconstructed, patched together from photographs and stories told at dinner. Elizabeth Loftus, the legendary memory researcher at UC Irvine, has demonstrated just how malleable human memory is. She has implanted entirely false memories in adults with remarkable ease. Events that never happened, complete with sensory detail and emotional resonance. If false memories can be implanted that easily in adults, imagine what is happening with the soft, freshly poured concrete of a 3-year-old's brain. Every story your family told you about your childhood literally became part of your memory. You did not re-experience those moments. You just heard about them enough times that your brain claimed them. You have been constructing your own origin story your whole life. And most of it is fiction. So here is where we land. You started this video thinking that forgetting your childhood was just some annoying glitch. Some quirk of your lazy brain not bothering to hold on to things. But it is not a glitch. It is a feature, sort of. Your brain, in the process of wiring itself into the most complex structure in the known universe, had to make some sacrifices. It chose growth over storage. It chose the ability to form new, flexible, powerful memories over the preservation of early ones. The brain you have now, the one understanding these words, laughing at neuroscience jokes. That brain was built on the ruins of your earliest experiences. You cannot remember them because they were used. They were transformed into you. That weird, shapeless void before age 3? That is not absence. That is foundation. You are literally standing on your own forgotten memories right now. You just cannot see them because they became you, which is somehow exactly as unsettling and comforting as that first question felt. Back at the beginning, when you realized your brain had been keeping secrets from you this whole time. Drop a comment with the first memory you think you have, and whether you actually believe it is real. Subscribe for a new video every single day. Your brain needs the workout.